In this module, I want to talk about hacking web servers, which leads up to our next module of hacking the actual web applications. So let's take a look and get started. All right. So first thing is to understand the landscape of what happens out on the wild, wild web. All right. Product line. IIS has about 17% of the market. Apache has a whopping 65% of the market, mostly because of the hosting services. It's really easy to kind of duplicate and virtualize Apache as opposed to IIS. Nginx comes in at 13%-ish, and then everything else, Google, Light, they'll make up the rest of the market space. All right. So most of what we do here is either going to be Apache-based or Windows-based. Impact. The results of what happens in the web server world if things were to go wrong, right? The most obvious one, website defacement. This is where somebody gets access to your stuff and puts the, some other banner or something on your homepage. It basically says, hey, you've been hacked by so-and-so. Okay. Ultimately, that can lead to some sort of compromise. Yet to really determine what compromise means, but a compromise either in confidentiality, integrity, availability, authentication, user accounts, whatever it is. Okay. If somebody compromises your website, ultimately they can start tampering with the data. All right, so data tampering comes in very quickly. So it's either manipulating, changing the integrity or an attack against integrity to your web servers, or theft of information, right? Could be things like, credit cards or financial information or whatever it is, but nonetheless, an attack on integrity, an attack on confidentiality, or just stealing the stuff, data theft, okay? Or, what I think is more importantly, a pivot point. You get access to someone's web server, and that acts as a pivot point for you to get into the internal network, and then you can have your way with the organization. So we typically use this front-end, back-end approach. If you can tap into the front end, use that as a pivot point, now you can go after the internal things like Active Directory or internal DNS, etc., etc., etc. So there's all sorts of techniques that can be used here, okay? There's literally no shortage. And really, it does help to have a programming background here, not necessarily required, but there's lots of keywords and buzzwords to get, really confusing really, really quick. So stay with me. Directory traversal. This is really navigating the web server's directory in some way. We typically call this the ... / technique because that's an easy way to kind of navigate up and down the directory trees. So you may want to start with, wherever the web server is hosted, the directory that which the web server is hosted, do a ... / all the way up to the root, and then go back down and grab something like, command prompt or something like that. Also, HTTP response splitting. This is where the attacker sends code either to the client or the web server, but nonetheless it has to go to the web server, and you send multiple requests to the web server, and then you get multiple requests back. So it's forcing the web server to basically send multiple responses back, in which the attacker or the penetration tester can then take advantage of. Web cache poisoning, right? Whatever web cache is on the web server, if you can poison it and insert your own malicious code or something to that effect, well, then penetration tester can take advantage of that. SSH brute force, okay? This is really trying to get inside the encrypted tunnels. If you can get in there, whether, depending on the algorithm, but if you can get inside the encryption tunnels, good news for you, the penetration testers. Also, man-in-the-middle techniques. These are applicable here. Password cracking techniques. I have a little note here. Dictionary, brute force, or hybrid. Any of those are technically fair game. Form tampering. Command injection, sending a command to the server saying shut down, or give me the command prompt, or give me the IP config, or whatever it is, ultimately getting the application to execute operating system commands. Tampering with cookies, doing a buffer overflow attacks. There's a whole module on that coming up. Denial of service, right, or distributed denial of service, or cross-site request forgery, or SQL injection, or cross-site scripting, or even session hijacking. Notice that our web front ends are basically the portal in which all of these other style attacks can basically come into play. All right, so there's no shortage of really valuable pen testing techniques. So now that we've talked about a little bit of the techniques, let's talk about, well, why does this stuff even happen to begin with, right? It's because web servers are developers, and not all developers are security people, not all security people are developers. And frankly, everybody is lazy these days. So you have unnecessary files, unnecessary backups, unnecessary configurations. You haven't hardened your system, which increases the surface area of attack, which gives the penetration tester more options to go after, okay? Plus, there may be a security conflict between security and functionality. You know, functionality, we want ABC 1, 2, and 3 to happen, and then security people are often considered the naggers of, oh, well, you can't do that because of the ABC or whatever it is. Well, if you typically the functionality part is going to win, right? We want the applications to function. Now, security people aren't really people to go making everybody's life miserable, as some say, but somebody's got to put the fun in functionality. I'd like to think the security folks are the guys that do that. Default settings. If there's default settings, default configuration, default accounts, well, the pen tester is certainly going to try to take advantage of them. Permissions, default permissions, right? What directories are set up to read, write, or execute. And if you can go after an executable directory, great. Like, for example, if I can upload a PHP file to any directory that's executable, well, now I can upload the file to that executable directory, the PHP file. Now I can start running my own scripts and my own attacks from that. So you always look for vulnerable access control. Misconfigurations in whatever shape they come. Default accounts. For example, the first account normally created is typically the administrator account. Second is normally the guest account. So the attacker knows this and is certainly going to try to go after that in terms of enumerating the accounts. Also, plenty of security bugs and flaws. Remember, we're in the business, the industry is in the business to make money. So there's always a rush to get things to the marketplace. So we don't take this rigorous security development or software development to the point where it's just perfect. It's normally get it out there, and whatever security weaknesses we find, we'll go ahead and patch and hotfix, etc., etc. Also, temporary certificates or temporary SSL. Let's say that you protect the login features of your website, but as soon as you log in, then you go back to clear text. Well, that's a field of dreams for a penetration tester, because now you're outside of the encrypted session. Yeah, or improper authentication, right? How about no hardening? Right? Therefore, you have a large surface area of attack that gives the penetration tester tons of space to go after. Or the fact that Joomla, Drupal, and WordPress, now anybody can be a programmer, right? So literally, grandmom could go to WordPress, start downloading it, and a few clicks later, she could have her own point-and-click website. Well, grandmom is probably not going to be a penetration tester. Apologize to all the grandmothers out there who are penetration testers. Okay, you know who I'm talking about. All right, it's basically programming out of a box. All right, if anybody can do it, well, then you subject yourself to the rest of the internet, and anybody can start probing your websites. Let's go up to methodology. The penetration testing methodology here is relatively simple, right? You basically do some information gathering. You footprint, find out your surface area. Is it Joomla? Is it WordPress? Is it Apache? Is it IIS? Is it Nginx, right? What does your destination look like? Just try to enumerate and footprint those services. In some cases, you can even just mirror the website. I am not a fan of mirroring tools because it's pretty aggressive, at least from the log file analysis point of view, because when you're looking at log files, it looks like, just the whole website's getting ripped down. I don't like mirroring, but I do like mapping out a directory or an application through what appears to be normal browsing activities. And this is where tools like the Burp Suite come in play, because as you naturally surf, it slowly starts building that directory structure without just ripping the whole thing down. And then finally, doing vulnerability scans and then exploitations. So you have to know what the weaknesses are so that you can ultimately exploit them. This is where the Metasploit framework has literally been wonders for the world of penetration testers, because with a little bit of expertise, you have just tons and tons of vulnerabilities, exploits in which take advantage of those vulnerabilities. Okay, a couple more whys over here. The penetration tester is always looking for error messages because just like from a functionality point of view, you need an error message in order to fix something. Well, a penetration tester needs an error message or some sort of verbose logging to ultimately give the penetration tester more ammunition to go actually after. Plus anonymous users or any sort of sample configurations or scripts, these are all valid for the pen tester. Remote admin capabilities, since we're all over the web. Well, hey, nobody wants to go to the office to do anything anymore, so let's take advantage of remote administration. That becomes a problem now because hackers can go after those remote admin portals as well. Any sort of unnecessary services or misconfigurations. Those are also additional features of why. So now that we've got the basic methodology of web server hacking, let's look at some of the most common countermeasures in the grand scheme of things anyway. So patches. You should have a patch management process at this point. If you don't, that's a problem, okay? Alternative sites versus alternative servers. Well, in the world of business continuity, we have alternative sites, hot sites, warm sites, cold sites. You can also apply that similar style thinking to an alternative server. In other words, if your primary server goes down, what about having a hot standby or maybe even a cold site, all right? That way you can keep your business up and running. Don't do your testing in the production environment. It's real easy to go, okay, well, it's just a little file we need to upload it and be done with it. But realistically, all of the testing should be done in a testing validation environment, and those changes should go through a change control process and then ultimately get to your production environment. Also, make sure that you've got backups, and if you require high availability, make sure you can literally flip a switch and go to another server. Another countermeasure, hire me. All right, what that means is hire someone like me to come in, show you the weaknesses, and tell you what you're going to need to fix them. And then you can either we'll fix them or you hire somebody else to fix them, but hire someone like ourselves, all right? Get us involved. We have too much of an opinion and expertise on this stuff for you just to blatantly ignore it. So the hire me concept is, don't be cheap about this stuff, right? You're always going to pay for it. Your only choice in this is it's cheaper proactively upfront or much more costly if it's going to be reactively. If you have to detect and correct, that is always 10 times more expensive than just proactively getting an opinion to have a penetration tester come in and look at this stuff, okay? Good protocol analysis. If you're using things like SMTP, POP3, IMAP, monitor that stuff. If you're using directory services like LDAP or Active Directory, monitor it. Whatever your web service architecture looks like, actually monitor it, right? Do your protocol analysis. Find out what's normal, have a baseline, and be able to compare against it. Monitor accounts. That's another very, very easy one. How many useless accounts get created in your web application? Are you disabling them? Is there some sort of manual approval process? Or can anybody just create an account for the sake of creating an account? Okay. Nowadays we associate, the growth of accounts with productivity, and we don't want to delete anybody's account for fear of making them upset. But realistically, creating an account and validating an account should go hand in hand these days. Also, monitor the files in the directories. You may see a file uploaded to a website, but an exploit might happen 2 and 3 months later. They're just uploading the file to the website to see if anybody's looking. All right? It's kind of like breaking into a house. You might break in, be able to pick the lock. Well, that might not be the best time to actually go rip out the TV set out of the house. You might want to just get access to the house and then come back a month later when the people are on vacation and then take the TV. All right? Using an analogy from the physical world. Okay? Encryption. Encryption, encryption, encryption. You can never encrypt enough. At the network layer with IPsec or some equivalent, or at the application layer, SSL, TLS, or some equivalent, especially application layer encryption. Use good architecture, right? One of the things that happens in the home environment is it's really easy on a Linksys router to go ahead and move something virtually from the inside of your network to out on the DMZ by a click of a button inside your Linksys home router. Well, that obviously, if you're doing something out of your home, that may be applicable, but you're certainly just at a click of a button putting that whole server right out on the internet. Well, you wouldn't want to take that same approach in the corporate environment. That'd be the equivalent of like putting your security database right out on the internet, at a click of a button. Have a good architecture. Separate your presentation, your application, and your data into 3 separate zones, and monitor that with firewalls and intrusion detection, and et cetera, et cetera, et cetera. So use good architecture, not just your classic, academic DMZ picture, okay? Actually separate it out. There's plenty of good resources if you actually want to know what good architecture looks like. Next, vulnerability scanning. Do it yourself. Use tools like NIC2 or WIC2 or Nessus or any of the top 10 vulnerability scanners out there, and see what your own vulnerabilities are proactively yourself, and then fix the vulnerabilities, or at least validate that they're accurate. Don't just not do it. That's literally like, driving down the highway, with no safety mechanisms whatsoever, okay? It's a dangerous world out there. The world of the internet is no different than literally driving on the highway. So find out where you're weak. You just don't get in your car and find out that you're, wait to get into an accident to go, oh yeah, it's because of, my tires were bald, didn't have any tread, right? Proactively seek this stuff out. And then lastly, the concept of data loss prevention, or DLP, right? These tools typically sell themselves because you can get a loan or a piece of equipment for data loss prevention, and you can see as you're bringing stuff in the front door, somebody else is taking the stuff right out the back door, okay? So data loss prevention technologies are put in place to go ahead and define what good criteria is, or what sensitive information is, like social security numbers, emails, accounts, banking statements, et cetera, et cetera, et cetera, to monitor that, and so that if you see someone, emailing a social security number out, then that information gets quarantined, and you have to get an exemption if it's an authorized, legitimate use of that. So data loss prevention has really only come out in the last, couple years or so, and started being mainstream. Remember, we didn't have patch management processes or robust change management processes either, and it's just now that everybody's familiar with patch management or change management, but I got news for you. I've seen plenty of change control boards and patch management processes, and most of them that I've seen, in my opinion, are a joke, okay? They don't serve the purpose. And here's how you know if you need help in the change management or patch management process. If everybody complains about it, you're not doing it right. Remember, change management is really your proactive way of getting into your environment to detect and correct things prior to going to production. Change management is not just, oh, we got to go to the change management board again, and we got to wait for this, right? If people are doing that stuff, then it's a very reactive process, and it's probably not, you're probably just wasting a lot of time and money, jumping through the hoops. Change management should proactively be saving the company money if it's done correctly. If it's not, if you have it and it's not being done correctly, then you've got to implement a Six Sigma methodology, find out your as is and what your to be should look like, and then go ahead and get to that ideal state so that it actually works and saves you money, okay? So all in all, hacking web servers, a lot of technologies, most of the market shares between IISs and Apache, easy methodology to go ahead and hack this stuff, lots of reasons why this stuff goes wrong, and a bunch of countermeasures that are basically common sense oriented. So this is the setup for what we see in the hacking web applications, which is the next module. So let's go ahead and look at some examples.